Let's mount up.
Hey guys, long time no see. I hope you are doing well in these crazy times that we have going on right now. We've been doing okay. It's been a little rough past couple of weeks though. Unfortunately, Lori's dad passed away very unexpectedly due to a heart attack. So we've been trying to deal with that. And so I was looking for something to do to, take my mind off things. And I was thinking about what little projects maybe I had lying around for our hunt. And I remembered that I needed to repair one of the shooting gallery guns. Not last year because we didn't set up the town since our son was just born, but the year prior, um, one of the guns fell apart. The kids were really rough on it that year, and it basically just kind of came apart, and the LED wire came out and everything. So it's been on my list that I needed to repair that, and in order to do that, I wanted to basically design and print a 3D part to hold the LED and act as the tip of the gun. So I thought I'd just make a little video here and show you guys what I did for that and walk you through it. So let's check it out.
All right, so this is the gun for our shooting gallery, and this is basically the condition that it was in after that Halloween. Aside from the tip here, I pulled that off myself. But basically, when I first made this gun, I went ahead and drilled out the end of this. This was attached on there, and I kind of had to pry it off there and broken it a little bit. But that's fine, because I'm not going to use this again. So I had drilled out a hole through there, and then this is the LED, this is the infrared LED that it uses. And basically what I had done is I kind of just wrapped around electrical tape on the end of this to kind of make like a makeshift barrel, because when you have the light here, the LED, you gotta narrow down the beam a little bit, because otherwise if it's just too wide, it just triggers all the targets in the gallery basically. So I was trying to limit that beam, and I didn't really have any other thing to use, so I just kind of used electrical tape and taped it in there. And you know what, it actually worked fine for several years, obviously. But now that I have the 3D printer, I thought, hey, I can do better and make a custom part for this. So I took my caliper and measured this guy and spent some design work and came up with a new part. So if you want to start 3D printing custom parts for things, you are definitely going to need one of these. This is a digital caliper. I don't remember exactly how much this ran, but it was pretty affordable if I'm remembering correctly on Amazon. But it basically allows you to measure things down in millimeters and inches, whatever you want. For 3D printing, you pretty much work in millimeters. All your 3D programs, that's the unit you're typically going to work in. So this is really helpful to have for taking measurements. So basically I used that and I went through this part to try to get estimates of the different sizes to create what I wanted, what I needed to hook into the end of the gun. So this was my first iteration of the part that I made, and it's actually in two pieces because when it was printing, it had a problem. Basically what happened is it was on the printer bed like this, and when it was printing, this bottom here shifted. Sometimes on the bed, if you have small parts, they won't stay adhered, and then obviously you start to get issues past that. I did actually check on this one, and I didn't happen to notice it because it just kind of like shifted off. It was a new one for me. Normally when things go wrong, it's like you've got a big mess of filament everywhere. It just turns into a huge pile of spaghetti basically, and then you cancel the print and start over. I didn't notice that in this, but once I had this, what I did is I pulled it apart, and that allowed me to test it and see if it fit. Well, it turns out that it didn't fit on the barrel of the gun. So I measured it and thought I had it right, but it wasn't. Basically what happened is there's two concentric circles basically, and I think I put them too high. Well, whoop, there we go. Okay, I was trying to get this so you can see. I got it too high, so it just didn't line up. So even if the print would have had printed correctly, it wouldn't have worked. The other problem I ran into is this hole is 3 millimeters, which is what I measured the LED to. But when you print, you never get exactly what you're designing for because there's always some variance on when it's printing out. And so this hole ended up being just a little bit too small for the LED, and it wouldn't slide in there. So I had to fix that in my design. So what I did next is basically print a small test print to get the fit right. I noticed on the barrel that it was kind of, it was a little bit squished, so it wasn't actually a true circle. So I thought maybe, hey, if I kind of stretch this out a little bit and make it more like an oval, that might work. But that actually didn't work either. And it turned out that I just needed to move the circle down. So I got this part, and I was able to slide that on and test the fit, and it worked perfectly. So that's just something you learn as you mess around with these things. But when you're designing, it's best to try to figure out a way to make a test part. And this is, very small, so this took 5 minutes to print. It was no big deal. It doesn't use a lot of filament. And then that way you have a solid base for your part design. I also printed out another disc here to test the fit of the LED to make sure that that was good. And I think I just had to increase this by maybe like 0.25 or 0.5 millimeter. And this was perfect.
All right, so here's a look at the completed 3D part here in the program I'm using. This is called Autodesk Fusion 360. It's definitely a more advanced program for doing 3D design work. There is a kind of a more basic version that's called Tinkercad. And I believe you just go to tinkercad.com. It's totally free, and you can get going with that. There's lots of tutorials and stuff on YouTube for that. That's where I started. And it's a little bit easier to get going with making your own stuff. And then you might find that you want a little bit more advanced functionality, and that's why I started using this. If you have any kind of experience doing CAD work, I used to do that for a while for school, and you'll feel right at home in this because it's basically, a lot of the basic stuff is kind of AutoCAD, and just a little bit more complicated on top of that. So anyway, this basically allows you to draw everything out. You kind of start in 2 dimensions first, and I can show you what that looks like. I created it's called a sketch, and this is the drawing, and you put all your dimensions in there in millimeters, and like I said, you measure off the part or kind of figure out what you want and try it out, and then put it all in there, and then you do all your modeling. I'm not going to go into how I actually made it because that would take forever, and there's probably lots of other tutorials out there that would do a better job than I would. So yeah, I'm not going to get into that, but it kind of just shows you here. This is a section here for a screw to hold it in place, and it's the sight, and then this is the barrel that the LED will go onto, and this will slide onto the end of the gun and hopefully work out really well.
All right, and this was the final result. This is the 3D printed part that I'm going to use on the gun. It's got this barrel here to help direct the beam down. I have not tested this on the gun yet. Unfortunately, some of my shooting gallery stuff is kind of buried in the shed there. So it's going to have to wait until I get to that. Worst case scenario, if the beam is too wide still, I can just kind of go back into the 3D program, and I would probably add something on this side to kind of narrow it down. In one of my examples that I had for an infrared shooting gallery gun, this was just like a little slit. It was just like a little rectangle. So I could potentially just kind of add something on the front to take care of that. But this guy, what I will do to reassemble is take this and just go ahead and glue the LED in there. Probably with hot glue or something. I was trying to make it so that if I needed to repair this in the future, like say I needed to replace this LED, I could this right here is a screw hole. So I was thinking I could basically slide this on and then screw it in place. And if I ever needed to replace it, I could just simply take that off and replace that part. So I'll probably just use like hot glue or something to glue this in. And I should be back in business.
Well, I hope you enjoyed this video, guys. 3D printing really is a cool hobby. It's super useful for anything around the house. I find myself designing and printing little parts for all kinds of random stuff. Even if it probably made more sense for me to go buy something, just having that option to make it myself is pretty cool. And obviously, there's all kinds of things you could use this for in your haunt and for Halloween. for example, the talking skull that I've been working on. So I'm really hoping to get back to some projects here. I definitely would like to get that photo booth completed and that talking skull and all that good stuff. Who knows what's going to happen this year with Halloween with this whole pandemic, but as of right now, I am planning to set up regardless. So even if COVID makes a resurgence and tries to cause problems again, I'm going to still set up. So I will hope for the best and go from there. So hope you enjoyed, guys. Thanks for watching. Stay tuned, and hopefully I'll have some more for you soon. I'm going to get started as early as possible this year because it will be a challenge with all the children that are running around this house. We'll keep adding more. And I'm telling Lori, no more children. She wants a girl. I can't handle any more children. I don't know what's wrong with her. All right, guys. Well, I hope to see you soon, and take care.